Okay, today we're in Inequalities Lesson 3. So today we're going to be solving multi-step inequalities. Now, you're going to see a lot of similarities between this lesson and when we learned multi-step equations. Okay, and there's an acronym that we can go by to help us remember the order that we're supposed to solve multi-step inequalities. Okay? And that acronym is Don't Call Me After Midnight. Don't call me after midnight. The D stands for distributing, the distributive property. The D stands for distribute. Go ahead and fill that in. The C stands for combine like terms. The M stands for move the variable. If you have variables on both sides of the inequality, move the variable. The A stands for add and subtract. The M stands for multiply and divide. Okay, which I would do last. I would multiply and divide to solve for the variable. All right, so we're going to kind of progressively make our problems a little bit harder today. We're going to do, I think it's 6 of them. We're going to do 6 problems and then 1 word problem, or scenario problem, I like to call it. Word problem, we kind of tend to cringe over that, right? But it's a scenario that we're going to kind of unpack at the end. All right, so solve the inequality. Let's look at the first one here. 5c plus 2 is greater than or equal to negative 27. Well, do I have distributive property in this one? Is there distributive property? No. Are there like terms to combine on one side of the inequality? No, there's no like terms. And there's no variables on both sides. So this is actually what we would call a two-step. Y'all paying attention? A two-step inequality. My next step says to add or subtract. And if you remember the way you learned last year, we kind of drew a heart around the number connected to the variable. We said those guys are best friends. They stay together the longest. So we move the 2 to the other side first. Okay? So how do I get the 2 to cancel to the other side? What do? Subtract it. Does everybody agree that 2 minus 2 would make this cancel? Okay, actually, let's make that a 3 so this works out to be a little more even. Okay, so let's subtract 3 to the other side. All right, no biggie. Okay, so now 5c is greater than or equal to, what's negative 27 minus 3? Negative 30. Okay. Now, what would I do to both sides to solve for C? Divide by 5. Now, let me ask you this. Is this a scenario that I would have to reverse my inequality?
No. Yes. No. Yes.
No. Is there a negative connected to my variable? No. So, even though there's a negative on the other side, that has no bearing, okay? As long as there's no negative connected to my variable, I leave my inequality the same. So C is greater than or equal to negative 6. All right, so now I just want you to come over to the side, and we're just going to do a quick number line. Remember, 3 numbers go on your number line. The solution goes in the middle, negative 6. What number is 1 unit less than negative 6? Negative 7. What unit is 1 unit more than negative 6? Negative 5. Would this be an open dot or a closed dot? And which way would my arrow go? To the right. And then you draw the arrow on the end. Okay, all right, so any questions on how I solved the first one? Just a real basic 2-step inequality. All right, so let's look at n over 2 plus 3 is greater than 12. I want you to try to get through step 1, maybe even get to the end, get to your answer. Try to at least get through step 1, possibly step 2. Okay? So this is another two-step inequality. All right, Micah, what do you think you would do first? Oh, we're doing n over 2 plus 3 is greater than 12.
First, I would, KFC.
Not KFC yet, no. But we will, because you see that fraction there, so you know that's coming. Sabrina? Subtract 3. Remember, we want to add and subtract first. Okay? So we get n over 2 is greater than 9. So how could I get that fraction to cancel out, Brody? KFC, so what would I multiply by? 2 over 1. Okay, 2 over 1, not 2 over n. If you multiply by 2 over n, you're going to have to multiply the other side by n, and you're not getting it by itself then. Okay, so you multiply by the reciprocal, but you want n to remain. Okay, now you multiply the other side by 2. N is greater than 18. N is greater than 18. All right. How many numbers belong on my number line?
3.
Okay, so 1, 2, 3 numbers on my number line. What number in the middle?
18.
What number to the left?
17.
What number to the right? Open dot or closed? Open. And which way does my arrow go? To the right. Okay. All right. Any questions on the first two? All right. So those are going to be just two-step inequalities. All right. Okay. So now let's look at the next two over here. Now these are going to progressively get more involved. What do I mean by that? Well, what do you notice about this first one? 5x minus 10 is less than or equal to 3x plus 4. What do you guys notice? Just tell me. What do you notice? Okay. There is a variable on both sides of the inequality. Well, just like you learned when we did equations. All right. Is this looking familiar to you guys? All right. It should. Okay. When we learned equations, we said we want to move the smaller value to the other side to avoid having a negative. Well, in this case, we really want to avoid having a negative so we don't have to reverse our inequality. Okay? So, which one, 5x or 3x, is the lesser value? Tell me. Which value? 3x. So, if I want to move the entire term, not just split it up to solve for x, but I want to move the whole term to the other side, my rule says to do the opposite. Is 3x positive or negative? It's positive. So I would subtract 3x from both sides to move it to the left side. All right, so 3x now cancels. All right, do you see that? Let me ask you this. If you move your x's to the left, what's going to happen to your number? It's going to move to the right. It's like a swing motion, guys. If you move your variable to the left, your number will move to the right. We can do that in one step. Move your variable to the left, and now you will add 10 to move it to the right side. Okay? Negative 10 plus 10 cancels. Now we bring everything down. All right. What's 5x minus 3x? 2x. Is less than or equal to what's 4 plus 10? 14. Now, how do I solve for x? Divide by 2 both sides. Do you guys, are y'all following me when I say to do that swing motion, move your x's to the left, so move your numbers to the right? Okay, so now x is less than or equal to 7. All right, so let's get that on a number line. All right, what number goes in the middle? What number goes to the left? What number goes to the right? 8. Open or close dot? Closed. Arrow going to the left. All right. Fourth problem, number 4. 2 times 2a plus 1 is greater than or equal to 6a minus 10. All right. Anybody want to take a shot at it? What do you think you're going to do first? Any takers on that? What do you think, Sabrina? Distribute. When I distribute, I must multiply the outside term by everything inside the parentheses. What's 2 times 2a? 4a. What's 2 times 1? Positive 2. So that's why there's a plus sign. Is greater than or equal to 6a minus 10. All right, I'm going to pause here for a second. I want you to decide which way you will move your a's and which way you will move your numbers. Try to get through on this second step here that we did on the top one. You try to do the second step here and move your terms. Okay, so I need you to move your variables. That's the M part of our acronym. Move the variable and then move your numbers. All right, which A term did you move? Kalani, which one did you move? Which one did you subtract? Did you subtract 4a to the other side or 6a? Okay, so we want to subtract 4a to the other side because it's the smaller value. So if I'm subtracting my a's to the right side, where am I going to move my numbers? To the left side. Did you add 10 to the left side? Did you guys do that? Okay, so now let's cancel out the opposites and let's bring everything else down. What's 2 plus 10? 12 is greater than or equal to 2a. What's the issue here that I need to correct before I can solve? A has to be in front. Do you see how the inequality is closed off towards the 2a? Okay, I'm not reversing my inequality here. I'm keeping it closed off towards the 2a. Okay? The issue here is if I do not rewrite it, I run a very high chance at graphing this incorrectly. Okay? Now I can clearly see A is less than or equal to 6. All right? Chances are, if you forget to rewrite it, you're going to think it was a greater than sign, but it's not. Okay? 6 goes in the middle. Open or close dot. Closed and arrow going left. Okay, did anybody get that right? Anybody get it right? Okay, any questions? Do we have any questions, guys? Let's do our last two problems. So 2 times k minus 5 is less than 2k plus 5. I want you to go ahead and do your distributive property. Okay, go ahead and do the distributive property here. Right? Did you get 2k minus 10 is less than 2k plus 5? Do you guys remember your special solutions? Your special solutions, your infinitely many solutions and no solution? You guys remember those from equations? So whenever I have variables on both sides, I must choose the lesser value of the two. Which one is the lesser value, 2k or 2k?
2k.
It's the exact same number, right? So when you see the exact same variable, what happens when you try to subtract it to the other side? The variables cancel. So when you see the variables cancel, you know that you have a special solution. Okay? So now I want you to bring down what's left. Negative 10 is less than 5. Is this a true statement? Is negative 10 less than positive 5? Yes. So your answer, with equations we said infinite solutions. With inequalities, when the inequality statement is true, we will say that all real numbers are a solution. All real numbers are a solution. So if what's left is true, then all real numbers are a solution. And I just realized my other inequality got messed up. So I need to, I'm going to do this. All right, I'm just going to write it. Is greater than negative 12n plus 5. Okay, for some reason it got bumped down. All right, so now my next inequality says negative 4 times 3n minus 1 is greater than negative 12n plus 5. So first thing I do is distribute. What's negative 4 times 3n? Negative 12n. What's negative 4 times negative 1? Positive 4. Is greater than negative 12n plus 5. Okay, so now when I try to move my variables, what do I see? The same exact variable on both sides. Now I immediately know that I have a special solution. Okay, these variables will cancel out. They're the exact same. So now bring down what's left. 4 is greater than 5. Is that a true statement? No. So your answer is no solution. No solution. Okay? So when you bring it down, if it's true, your answer is all real numbers. If it's not true, your answer is no solution. All right? Any questions? Okay. All right. Last but not least. Okay. An amusement park. All right. Anybody ever been to an amusement park? Has anybody ever been to one, maybe like the fair or something, where you actually pay per ride?
Yes.
Okay. So that's the scenario we're looking at here. But remember what I told you yesterday. You have a commonality, which means a common themes across all of these problems. You will always have some kind of total. You will always have an inequality symbol, a comparison. You will always have an operation, multiplication, division, subtraction, addition. Okay? So let's read this together and let's try to piece it together. An amusement park charges $5 for admission and $1.25 for each ride. You go to the park with $25. What is the maximum number of rides you can go on? All right, so when you read this, do you see a total amount? Do you see some kind of a total amount? $25. So that's going to go on one side of the inequality by itself. Okay? Now, you know that you're going to have a variable. Which value do you think would be connected or affected by the variable? Which value do you think would be affected by the variable? What is it? No. Would be connected to the variable. Do you think $5 for admission, do you think the number of rides affects the $5 that it takes to get in? No. It's $5 to get in regardless, okay? What is affected by the number of rides? The cost per ride, right? So that's how I know that R goes with 1.25. So now tell me, how does this combination of values need to compare with 25? Does that combination need to be less than 25, greater than 25, less than or equal to? What do you think? Think about the scenario here. Okay? You have to spend, so all this money over here, $5 to get in and $1.25 per ride. You have to spend less than that or equal to that amount. You only have $25. So this combination of the money you spend has to be less than or equal to how much money you have, right? You can't spend more than you have, right? Right? That would be called going in debt. And we don't want to do that. All right, that's our problem in America, isn't it? We just put it on plastic, put it on those credit cards, and don't worry about it. As Americans as a whole, we buy stuff we don't really need. Okay, that's a whole different subject for a different day, isn't it? That's like an economics class pretty much, but career skills, yeah. Okay, all right, so now I have a two-step inequality to solve. What would I do first to solve this inequality? Subtract 5. Right? And that makes sense, right? You paid $5 just to get in. That's not affected by how many rides you ride. So now how much money do you have left for rides? $20. That's what this step is saying. I have $20 left now for rides, and that's if I don't buy any snacks. Okay, we didn't even factor snacks in. Okay? So now, how do I solve for R? Divide by 1.25. Divide both sides by 1.25. So R is less than or equal to, what's 20 divided by 1.25? 16 what? 16 rides. Someone put this solution in a sentence for me. Put this solution in a sentence for me. Can you put this solution in a sentence? What does this solution mean? What is it telling me? Noah?
$20, you can ride at most 16 rides.
All right, you can ride 16 rides or less with the amount of money you have. Otherwise, you got to get more money from your parents because we're not going to go in debt over a fair ride, right? Okay, so only spend the money you have. All right, that's all you need to know for lesson 3.